So let's move forward. So the problem statement, you can see the we have to write 8085 assembly language program, okay, where you have to add two decimal numbers, right? Okay, so and we have already understand the how we are writing program to add two different hexadecimal numbers and storing the result as well as carry, right? Here only the difference is that here you have to the uh, write the program for adding two decimal numbers. So this is the program statement. Okay, so in this program statement you can see that the data. Okay, so 8000 and 8001. So in this problem the location 8001 is having the two decimal numbers. Okay, so you just see what I have done. I have not used any base, right? I am not writing anything like hexadecimal. Okay, so like this one, I am not writing this hexadecimal because actually I want to add to decimal number. I want to get to decimal numbers. Okay, so if I write here D, then I am my intention is it is decimal numbers, but while I am storing this value 98 at the location 8000 through that simulator, it will store that value as a hexadecimal number. So this type of confusion will arise. So which uh, which decimal or hexadecimal, which one I have to write? So it is better to write nothing. It is better to write nothing, so that what I have written in the note section, I have written that the given numbers in decimal. Okay, this is the decimal number, this is the lower byte of result, and this is the upper byte of result. So this is actually the thing. Here the two decimal numbers are stored in the uh, your two location 8000 8001, and you have to store the result into the 9000 and 9001. Okay, so to perform this lab, you have to perform three cases. You have to solve three cases. Okay, so do you have that note with you? Means that node where I have shown the operation of DAA instruction. If you have that node, then you can see that I have worked with that node three different data set, right? So I am just writing that data set consecutively. So first data that I have worked with, that is your 96. Here you can write 69. So this is your first pair of data. Okay, so this is 96, this is 69. Okay, then next pair of data is your 84. Here it is 92, right? So 84, so this is 84. This is the second pair of set, right? 92. So is it visible, or I should change the color so that it is visible more? 84, then 92. So I am writing three set of data that you have to check whether your result is coming correct or not. Okay, because the thing is that I'm just repeating the reason. Just 1 minute. So here you can see 96, 69, then 98, 99. So this is the number 98 and 89. Okay, so here I am writing nothing. Okay, so basically the logic, what is the logic behind this? So we are doing addition, so there is nothing new logic. Only to convert that added value into decimal, we have to use DAA instruction. And in the DAA instruction, there are two different cases, right? So in the DAA instruction, you can see three different cases, not two, three different cases. Which are the cases? So the case is, first is for the lower byte of the accumulator, right? So for those students who have not attended that class where I have discussed DA instruction, so for that, for them I am saying this thing for second time. Okay, so DA instruction is a kind of instruction that will convert the content of accumulator, okay, into a decimal form, right? So accumulator content is normally in 80885 is hexadecimal. So DAA will convert hexadecimal to decimal, right? So DAA actually convert hex to decimal, right? Now how it is converting hex to decimal? So this is the thing we try to understand here. So the way is, it will take the content of accumulator, okay? So suppose your accumulator this, okay, so let's say your accumulator content is something uh, fa fa, okay? So you have added two numbers, then you are getting a result as a fa, okay? So that means if I break that content fa into the binary format, then I am getting 1111, then 1010, okay? So DA at a time, DA at a time take lower byte, lower nibble, better say nibble, that means 4 bits, right? Bit, 1 bit, nibble is 4 bits, okay? So take lower nibble, okay, and check whether that value in the range of a to f, a to f, that means in the hexadecimal we have digits from a to f, but in the decimal we don't have that digit, right? A to f. So that means after addition, if there is a digit, if there is a digit like here you can see fa, there is a digit in the range of a to f, means a b c d e f, then what daa will do? Daa, so in the case of daa, at a time take the lower nibble and check whether that value in the range of a to f, and there is a war condition also there. So I'm uh, so or condition is there, so or condition I'm writing after that. So what it will do, it will add, then it will add add 06, that means I'm working the lower part, lower nibble, so it will not affect the upper nibble, so that means 0 part, and it will affect only the lower nibble. So 06 in hexadecimal, right? So this is in hexadecimal, so if I convert it to decimal, then it will give you this. So it will add this value to that digit, okay? So it will simply adding that 6. So there are actually 6 digits, a to f are your 6 digits, a b c d e f, 6 digits. So it is just adding 6 with that nibble, and the result is the in the decimal format, okay? So this is how daa handle the hexadecimal number to convert it into decimal. So this in one by one. So this is the first case where daa is taking the lower nibble, check whether that value in the range of a to f or not. If it is a to f, then what it will do, it will increase the value, okay? So it will then it will add 06, okay, with accumulator, okay? So this, and there is another case also. So another case is if there is a no if the value of the accumulator lower nibble is not in the range of A to F after addition of two decimal number, right, then it will also check what is the status of auxiliary carry, AC auxiliary carry flag, AC flag. So this is actually your auxiliary carry flag. So it will check what is the status of auxiliary carry flag, right, flag, and if it is set, okay, and if it is set, so if I better I write the or status of auxiliary carry flag is set, okay, for these two condition. DA at a time take the lower nibble and check whether that value in the range of A to F or status of auxiliary carry flag is set, then it will add this thing with this accumulator lower value, right. So this is your case 1 for the lower nibble. Now I am going to the case 2 where DA is handling the upper nibble. So here you see DA at a time take the upper nibble and check whether that sorry, whether that value in the range of A to F, same thing, and status of carry flag here. Little change because here this carry flag will, status of carry flag is set or not. If it is set, then it has to hit the upper nibble. So the value is changing from 06 to 68. So that means, so this, right, this value will be added to the accumulator. Okay, so basically the DAA instruction is very powerful instruction. It is doing the whole important work here. You see DAA instruction, it will after addition we have to use DAA instruction, and DAA will convert hexadecimal then to decimal. So here convert accumulator hexadecimal to decimal, right. So here I am taking an example. Here you can see this is an example where your accumulator content is FA, that means this is in binary. Okay, now if when DA, so when DA is DA is observing accumulator, and it can see that lower nibble, so you can see that lower nibble part in the range of A to F, then it will simply add 06 with the number. Or if it when after lower nibble part, it will go to the upper nibble and it will check whether it is in the range of A to F or not. If it is, then it will add 60. So that means it 06 needs to be added with this number, then 60 need to be added with this number. So I can simply add. So if I'm showing in this in the hexadecimal notation, so I'm simply add accumulator equals to accumulator plus 66, right. So this is the operation that accumulator will do. Okay, DAA will do. Okay, so you can see, so after for this given example accumulator content is FA, then DAA instruction will add 66 with the number, with this accumulator number. So this is the case 1, because here you have to take 3 cases. In my class I have discussed this thing. So there are 3 different cases are there. The first case is in the range of A to F lower nibble, in the range of A to F the upper nibble. So first case is this, where your lower nibble in the range of A to F, upper nibble in the range of A to F. Okay. So what is the second case? Second case is any of these two case, or okay, any of these two case A to F or A to F, and suppose you are taking the case where your lower nibble is not in the range of A to F but your auxiliary carry is set. So this is the second case where your lower nibble, so in this you can see this example 84 plus 92. So when you add these two number 84 plus 92, what you will get? You will get at the lower nibble 6, okay, and at the upper nibble you are getting, okay, so second upper nibble you are getting 8 9 plus 8 17, so it will give you a carry. So this is the case for the second one. So when you are adding 84 with 92, so you can get a carry at the upper nibble side. So what you will getting 06 at the one nibble when I am adding 84 with 92. So no problem for that, for this case, because 6 is valid decimal number. But when I am adding the upper nibble 8 plus 9, so it will give you 17, right? So in the hexadecimal format, it will give you uh, one carry. It will generate a carry. So as there is a carry in the upper nibble side, so in that case you have to add, what you have to add? You have to add 60 there. Okay, you have to add 60 there. So you are getting my point. So why you have to add 60 there? Because the upper nibble and lower nibble after addition 84 plus 92, both the digits are not in the range of A to F, but there is a carry. Okay, there is a carry in the carry flag. So carry flag is set. So that's why DAA will add what? Add the value 60 with the content of accumulator. So this is the second case, and the third case you can see 98 plus 99. So 98 plus 99, when you are adding these two numbers, okay, so what it will give you? It will give you a condition for auxiliary carry. Okay, so it will similar to the previous one. Well, it you can get a auxiliary carry. Okay, okay, so with compared to the first case, the third case, the difference it, in the first case you didn't get a auxiliary carry, rather you are getting in the range of A to F the value. But in the third case you are getting the result after addition, not in the range of A to F, rather you are getting auxiliary carry as well as carry flag. That means in that case also 66 will be added to the number, 66 will be added to the accumulator. So one by one by hand you have to do is, so what I have done, in my class I have taken a whole session on this, so that you can easily understand when I am performing this lab. Okay, so you can easily understand the logic. Okay, so logic is very simple, but the calculation is tricky. Okay, so here the program table is very simple. It is just a program table of addition numbers, only one instruction, extra instruction you have to use. Okay, so program table is very simple, logic is very simple, but the calculation part is the tricky. So what you have to do today as to submit your assignment, you just have to take any of the three cases, okay, and explain that case, any of the three cases. Okay, so you have to write the program table, okay, first, then you have to simulate, and then you have to take any of the three case and take and explain, means just calculation. So the calculation for any of these three case, not three, all three case, any of the three case. So this is actually today's task. Okay, and we will give you a total 1 hour time for this purpose also. Okay, 1 hour 15 minutes say. Okay, for calculation it will take more time. So 1 hour 15 minutes we will give you for this part, for this task to complete. Okay, but the logic is, you understand the logic. So basically the thing that is happening here is that when I am using DAA, it will perform all the internal hidden tasks. It will check the condition, this two most important conditions, this A to F range or auxiliary carry status, A to F range or carry status, and it will perform the operation accordingly, right? So you can easily write the program. So there is the algorithm. I have shown the algorithm here. You just have to, you just need to check what is the content of the, means you just need to set the memory location for the source, where is the data stored. You have to result location, you have to point out the register pair D, the similar to the previous program also. So there is a continuation process, so that you can easily understand. Then first number you are taking into accumulator, okay, and making a register C00. C is required for your carry. okay, then increase the next HL pair, and then you add the number with the accumulator, right? So just simple addition program, okay. Then at the fifth step, that is important, at the fifth step you have to use the instruction DAA, that is use decimal adjust accumulator operation. So that means that instruction you have to use here. Then check whether there is carry or not. If there is no carry, then just simply store the result. You don't need to increase the carry flag statement, right? Simply store the result. Else what you have to do, else you have to increase the C content, then store the result, okay. So that is the thing you have to do. Okay, now you can easily perform the task. So I suggest to write down the program table. So in the program table, this is the hint, you can easily do it. Okay, now I am giving a time 12:30. Okay, so it is 12 now, 12:30. Up to 12:30 you write down your program table, then I will show you the just that experiment part, the simulation part. Okay, hello. Okay, so it is 12:15. So let's see how much you have proceed in your program table. Okay, so can you see 1 minute, just 1 second, 1 second. This is the this is the word file. Okay, so you can see this word file, right? Okay, so what I am suggesting is that, just 1 second. So here is the program flow, right? So this is the algorithm. তিনটে আউটপুটের স্ক্রিনশট দিতে হবে না, ওকে। অভিজ্ঞ জিজ্ঞেস করেছে, তিনটে আউটপুটের স্ক্রিনশট দিতে হবে না, জাস্ট একটাই স্ক্রিনশটই এনাফ, ওকে। কিন্তু তুমি যেটা এক্সপ্লেন করবে তোমার কপিতে, সেই স্ক্রিনশটটা দিলেই হবে, ঠিক আছে। তিনটে ডেটা সেট আছে, যে কোনো একটা ডেটা সেট নিয়ে তুমি এক্সিকিউট করবে, করে সেটার করসপন্ডিং স্ক্রিনশটটা দেবে, ওকে। সো this for the first line, what we have to write. Okay, so here I can write the instruction. Okay, I'm just copying this thing, going to this. So you can now, this is the simulator section. Okay, so you can see the simulator also. So so step by step, if I explain the instruction, then you can easily understand. Okay, so you have to load the memory 8000 into HL, that means you have to use LXI. So I have used here LXI instruction at first line. Then you have to load the destination memory location, result memory location, that is at the 9000 into DE. So next line you can see the DE is initialized by 9000. So next is you have to take this say first number and make the counter C equals to 0. So I am moving 00 to C and taking the number first number into accumulator using MOV AM instruction. Okay, then you have to increase your HL pair to next location, and directly you can add the value of the next location with accumulator by add M, right? So I'm using that instruction add M. So that means the content of the accumulator and the content of the next memory location are added. So next is after add m you have to use DAA. So as I have discussed here, you, the fifth step, use decimal adjust accumulator operation, that is DAA, decimal adjust accumulator, DAA. This is the full form of DAA, decimal adjust accumulator. So I have used this instruction and there is no operand in that instruction. Okay. Then I have to check whether there is carry or not. If there is carry, then I have to increase that by INRC. If there is no carry, then I can directly move to the L1 that I am storing the result content of accumulator into D. Okay, then I am increasing the location, result location, then I am storing the content of C into A. That means I am storing the content of C if there is carry, of if there is no carry, because this is very important. Means the result is actually sometimes 16-bit, sometimes 8-bit. So you have to take care about whole 16-bit also. So here you can see when there is no carry in the 9001 location, you get 00 here, right? Okay, so then I am storing that content of accumulator, that is which was previously in C, into that location. Then I am ending the program. So this is the program statement, program flow. So here you just have to simply add two numbers, then use DAA and take care about the carry. Okay, so apart from the DAA instruction, the flow of the program, if I don't use this, then this is the exact program that we have performed previously in our lab sessions. The statement was that like that, adding two numbers and storing the result and carry into two consecutive memory locations, right? This is the program for that program. Okay, and if I add this instruction here, then the statement of the problem has changed. This is the now addition of two decimal number and storing the result of the decimal number into two consecutive memory locations. So you can see this is the this is how we can understand the flow of program for two different aspects using the same program code, just using a single difference of the instruction. Okay, so you understand this thing. Okay, so I am saving the program code. I am setting the starting address as 2000. Okay, now I am taking the in first value that I am showing is simply two decimal number, where first number is 24, second number is 21. Then when you add these two number, you will get 45. So 45 is such a number where there is no carry flag, there is no auxiliary carry flag, there is none after addition. Not the lower nibble, not only the lower nibble but also the upper nibble not in the range of A to F. So you understand, this is the simple most example for the addition of two decimal number where there is no conditions are satisfied for the DA instruction, for why in for whose for those cases to add 06 or 60. Sorry. So this is the simple example where you are adding two numbers in the decimal format, you are getting a result in the decimal format. No A to F digits are generated after addition, no carry is generated after addition, no auxiliary carry is generated after addition. So I am just giving these numbers, and okay, now I am save the program and I execute it. So after execution you can have 45, right? You can have 45 here and you will get 00 here. Okay, so this is the very simple case. So case 1, if you can note it at so just for your understanding you can also note this thing. Okay, so this is the case 1 where you are adding two simple numbers and there is no complexity arises. Okay, now I am moving to the next number. Okay, so here it is the number 96, then I am writing the number 69. So what you can see here, I have just changed the two numbers. Okay, so you just think what is the result? 0165 means 165. So you can imagine 69 plus 96 is 165. So you are getting 165 in the two consecutive memory location. 0 1, this is the upper bit of the result, and this is the lower bit of the lower byte of the result. So 0165, so you are getting the correct result. Okay, so what is happening here actually, both the numbers after addition 69 and 96 are in the range of A to F. Okay, so this is the case 2. So 6 plus 9 is 15. So in the decimal, which digit we use to represent F? 15, that is F. So after addition, okay, so after addition you will get FF. Okay, so if I just remove this and save and execute, so you can see I am getting FF. So this is actually FF after addition. Now I am using DAA. Okay, so it is now converted to decimal. So you are getting 0165. Okay, so you understand. So next case. Okay, so next case is your 84 and 92. So I am taking 84, I am taking here 92, I am removing what is there. Oh god, okay, no problem. 8002 has just appeared here, so this is not a issue, can delete it. Okay, so this is the thing. Okay, so I am just deleting this instruction. Okay, and I am okay, so what is the result? The result is now 116. So if you add these two number, what you will have to what is the result? 176, not 116, right? So you are getting 116. So that is actually the hexadecimal result, right? So you are adding two numbers and you are getting 116. This is in the actually whole thing is in the hexadecimal number. Now just you change it, insert this instruction and save it and execute. So now you can see, so you are getting 176. So you understand. So this is how you are getting the decimal number 176. So this is the case 3. Okay, so case 1, case 2, case 3 and case 4. And what is happening in the case 2? Case 3, what is happening actually in the case 3 here after addition? Okay, so here if I remove this thing, so if I save it and if I execute it, so after addition I am getting 4 plus 2, that is 6, no problem. I am getting 8 plus 9, that is 17. So there is no provision of representing a number 17 in a hexadecimal using 4 bits. Okay, this is there, it is totally impossible. So there one extra bit is required. So we require 5 bits to represent a number 17. Okay, that's why it is actually carry is generated and you are getting 1 in the upper nibble, right? So this is actually correct result in the hexadecimal format, but we want as a decimal format because we have given the numbers in the decimal. So here I am adding this, so it will give me the decimal value 76. So you understand the difference. Okay, so similar. So syllabus for the corresponding to the next example. Okay, sorry. Next example is 98 and here your 99. Okay, and I am not using DA. So you can see. So you are adding 98 with 99. So 9 plus 8, 17. So there is no provision of getting 17 in a 4 digit. So I will get 1 there in the lower nibble part, and 9 plus 9 18 plus the 19 actually. So because 1 is coming from the lower nibble, so 9 plus 9 18 plus 1 is coming from the lower nibble, so 19. So there is no provision of giving 19 in the through these 4 digits of the hexadecimal upper nibble. So I will get there 3. So in the if I execute this thing, so I will get 31 in the accumulator, okay, and a 0 1 in the, sorry, 0 1 in the next location. So basically in the decimal, in the hexadecimal, the result is correct 0 1 3 1, but we are not interested in the hexadecimal. We are interested in the decimal, right? So that's why I have used here DA. So DA is there, and then I execute. So you can see the result is correct 197. Okay. So this is the fourth case. So total 4 cases we have understand. Among the first case I have not shown in the word file. This is very simple most case. So you don't need to show me. You don't need to execute with that value. That is for just for your understanding. So among these three different cases, you have to take any of the 3 cases and execute that thing in this simulator, and corresponding calculation you need to show in the manually করব কি করে এটা, okay, manually means if you attend my class, okay, because I will suggest you to refer my note, okay, refer my note on in that for the instruction DAA. There I have shown you how manually we can calculate. You just need to take the number, okay, then convert it into decimal, okay, and calculate the summation of these two number in the okay, you at first means, okay, let me explain just 1 minute. Okay, suppose I am taking this case, so this is the 98 is the number, 99 is the number, okay. So for manual calculation you just write this thing. So I am showing you this here. So just you can see this word file, right? So manual calculation I am just showing. So suppose you are get taking 98 and 99, then you have to convert it into binary. So this is actually in hexadecimal. Now hexadecimal to binary you need to convert, okay. So then after binary conversion, so 1001 and 1000 next, um, so 1001 then 1001, okay. Okay, so then I have to add, okay. So what is I am getting here? I am getting 0001, okay, but in the meantime I am getting a auxiliary carry, okay. So and then here I am what I am getting 30011, and I am also getting a carry. So here I have to mention that I am getting a carry as well as I am getting auxiliary carry. So that's why I have to add 66 with this result. So that's why here I have to add 0110 then 0110, okay. So adding this thing with the value, okay. So thing that is coming as 0111 and okay, along with the there is a carry, okay. So result is actually is like this. So in the 9000 location I am shifting the value 97, okay, and and the 9001 location I am shifting the value 01. So this is actually the calculation. So this is actually the condition why I am adding these two things. Okay, for this example, if you take different example, then it will be something different will happen in this in this box. Okay, you understand how you show. Which example is to be done? Any of these three instruction, any of these three example. I have taken three example: 9669, 8492, 9899. So you can copy it. Okay, ম্যানুয়াল ক্যালকুলেশনটা এটার সাথে সাবমিট করে দাও। ওকে, সো ইট উইল বি ইজি, মানে তোমাদের আন্ডারস্ট্যান্ডিং। সো আই এম অলসো, মানে আমি টাইম স্লটটা আই এম অলসো ইনক্রিজিং। সো আই এম জাস্ট এন্ডিং দি সেশন অ্যান্ড ইউ উইল হ্যাভ 1 hour 15 minutes। ওকে, হ্যাঁ, কমেন্টস লিখতে হবে লাস্ট টাইম, সেই জন্য আই হ্যাভ গিভেন ইউ আ পার্টিকুলার ফরম্যাট অফ প্রোগ্রাম টেবিল, বিকজ তোমরা কি করছো, তোমরা সবাই নিজেদের মতো প্রোগ্রাম টেবিল লিখছো। ওকে, সো হেজি হয়ে যাচ্ছে জিনিসটা, ক্লিয়ার হচ্ছে না, ইভেন তোমাদের পক্ষেও সেটা ক্লিয়ার হচ্ছে না, বিকজ তোমরা কমেন্ট সেকশনটা অনেকেই লিখছো না। কমেন্টসটা তোমাদের তোমাদের নিজের আন্ডারস্ট্যান্ডিং এর জন্য, যে তোমরা প্রত্যেকটা ইনস্ট্রাকশনের অপারেশনটা বুঝতে পারছো কিনা। উই হ্যাভ টু গিভ দি পিকচার অফ সিমুলেটর অলসো। হ্যাঁ, simulation, program table, and the calculation. Okay, simulation, program table, and calculation. And calculation এ তোমাদের তো you have to take any of these three data set. Okay, so না না না, রিসাবমিশন হবে না, ঠিক আছে, নাম্বার কম পেয়েছো, ঠিক আছে, কোনো অসুবিধা নেই, you will get a better number next time. But sir, in case of upper nibble, why we are adding 06 instead of 60 in case of 98 plus 99, 98 plus 99, 98, 98 plus 99, we are, why we are adding 06 instead of 60? আমি কোথায় দেখালাম বলো তো, what I am, where I have shown 98 case, for the case of 98 99, right? Okay, let me go here. 98 and 99. Okay, for this case 98 and 99, you can see that two conditions are arised. So এখানে সেই জন্য আমি লিখেছি two conditions. After adding these two value 98 plus 99, the must my first question, whether the content of lower nibble in the range of A to F, my answer is no. Then I have to check also whether the content of auxiliary carry is set, my answer is yes. So that's why I have to add here 60, means 06. Okay, so I have to add 06. So that means this is for lower nibble. Next, my question is, sorry, next my question is whether the upper nibble is in the range of A to F, then my answer is no. But I have to check another condition, whether the carry flag is set, my answer is yes. Then I have to add 60 here. So 60 means 0110, then 0000. So basically I am adding two different addition. So in a single line, how I can directly add 66. So that's why I have shown here 0 space 0110. So this is the explanation. Okay, because আমাদের দুটো condition, so I think you can understand my explanation. Because we have to ask two question for lower nibble, we have to ask two question for upper nibble. Okay, so my first question upper nibble, স্যার বেরিয়ে যাই দেন, হ্যাঁ না হ্যাঁ তোমরা বুঝে গেছো, now you have to give your id, just you have to write your id here, after adding the id you can leave. হ্যাঁ এখানেও দিতে হবে, এখানে দিতে হবে, because I have to cross check here and there. And I hope that you are going to submit your assignment in the Google class within that stipulated time. Okay, so till now I have not received any assignment, but I hope that you will submit it by Saturday. So because Saturday is the deadline for the submission. Okay, and the topic that was covered in that assignment is totally the topic we have covered during this online class sessions, right? And no questions about the assignment will be discussed now, because after Saturday I will discuss. If you have any doubt, because then I will clear it after Saturday. Okay, so thank you. This is end of session. Okay.